Assalamualaikum warahmatullahi wabarakatuh to everyone that watch my video. My name is Nurul Haziqah Binti Zaifuddin, and in this video I'm going to present my final year project 1 entitled Evaluation of Electric Vehicle Performance Using Motion Sensor with Internet of Things IoT based data logger system. My supervisor is Dr. Khairul Anuar bin Mohamad, and my panels are Dr. Siti Amely binti Jumaat and Dr. Zulaily binti Mohamad. As introduction, the improvement of environmental awareness has led to shifting towards the use of electric vehicle technology that is much more environmental friendly compared to the internal combustion engine. Thus, the EV are evaluated for their battery level and trip distance, and also the analysis of battery consumption on distance, time, temperature, and load weight. This eventually will generate an insight in the mapping of the consumption of electric driving. Actually, most of these parameters can be obtained directly from the onboard diagnostic port of the electric vehicle. However, the automobile manufacturers are reluctant to release this out due to safety purposes. Therefore, the developed system device in this project will use to support this research on the EV evaluation and performance. There are three objectives in this project. First is to identify and analyze the factors and parameters affecting EV performance as a function of battery consumption. Second is to develop a data logger system to monitor the movement of EV through IoT platform. And third is to analyze and investigate the on-road tested EV parameter through the developed system by using data analytical tools. There are several limitations in this project implementation. First, battery electric vehicle BEV is used as the test vehicle. Second, the condition for testing and analysis of the EV parameter are only limited to the roadway and highway. Third, Node MCU will be used with a blink to measure the parameter during testing as a data gathering tools. Lastly, MATLAB and Excel as a data analytic tool will be used to investigate the relationship among the collected data parameter. I will explain the overall flowchart of this project implementation. It is decided that there are two methods of data gathering for the EV performance and evaluation, which are the manual assessment and also the development of onboard motion sensor. For the both assessment, I will perform multiple procedures of on-road testing. For the manual assessment, the data collection is directly through the vehicle dashboard, while for the development of the system device, the data collection is through IoT-based data logger system. And then as the result, the performance and the data analysis will be made. The electric vehicle you see in the screen is the electric vehicle used for this project. It is a BYD E6 compact MPV. For your information, it is a full battery electric vehicle, and its specialty, it has an electric traction motor, traction battery pack, and also a charge port. So this is the general specification of the EV, and most important thing is the full battery capacity is 80 kWh, which equal to 100% battery level. First, I will explain the method on the manual assessment. The procedure of the on-road testing will be conducted in three different conditions. First test field is the roadway, second is the highway short distance, and third is the long distance highway test field. The data gathering process will be made available based on these three test fields, and then the data analysis will be made. This picture shows the electric vehicle dashboard. So first we have the temperature, outside and inside temperature, the speed, the battery percentage, and also the trip distance. All these parameters will be observed and recorded during the on-road evaluation testing. In this section, I'm going to explain the evaluation condition in each test field. First is the roadway. This picture shows the simplified map of the on-road testing, which is from Jalan Seri Bengkal to Jalan Keluang with a total distance of 40 km. There are two evaluations conducted in this test field. First, the speed range is limited from 30 km to 60 km per hour. And then the trip distance, time, and speed are being observed in 5-unit intervals. The test is being repeated to 7 cycles, and the temperature are recorded in 7 time range. For the second evaluation, is the speed is made constant to 60, 70, and 80 km per hour, and the trip distance, battery level, and speed in 5 km interval is being observed and recorded. For the first result, I have plotted the battery level versus trip distance for each cycle. Here we can see that the battery level linearly decrease over trip distance with almost constant drop rate of 0.2% per kilometer. We further analyze this by calculating its battery consumption kilowatt hour per 100 km. So next, we make a relationship between the consumption of each cycle with its total trip. However, we can see in cycle 5 and 6, there is a greater drop rate due to traffic condition. So based on this graph, we can conclude that with maximum speed of 60 km per hour, EV can run a maximum 500 km range per one cycle battery, and the average drop rate is 0.2% per kilometer, which is equivalent to 60 kilowatt hour per 100 km. In the second result of the constant speed of 60, 70 and 80 km per hour, the average drop rate has a similar pattern as the result previously, which is 0.2% per kilometer. However, it is increasing when the speed is increasing. This can be described in the graph of consumption and trip for each speed. Here we can see that when the speed increases, the consumption will also increases, thus the maximum range the EV can go decreases. It is also analyzed that as the temperature increases, the battery consumption will increase. If we look here, the highest battery consumption is during the 1 to 2 p.m., which is during the afternoon, while the lowest consumption is during 9 to 10 p.m. at night time. The second test field is highway short distance of 90 km, which is from Tol Plaza Air Hitam to Tol Plaza Pago. The first evaluation, the speed variation is constant at 80, 90, 100 and 180 km per hour. For the second evaluation, the speed variation is 90 km per hour and 110 km per hour. The second evaluation is related to load weight parameter. So the load weight is constant at 160 kg and 230 kg for each speed. And then the trip distance in 1 km interval, battery level and speed are being observed and recorded. For the analysis, the data is only collected for a 25 km distance. Similarly to the roadway evaluation, the average drop rate increases when the speed increases, but it is constant to 0.2% per kilometer. In the consumption and trade, we can see that when the consumption increases, the total trip it can go also will decreases. This is the result for the load factor evaluation. We have 160 kg and 230 kg. For the same range speed and total distance, we can see that the battery level per distance for the heavier load is greater than the lighter load, as well as the battery consumption per kilowatt hour per km and per 100 km. The heavier load have a greater battery consumption. However, the lighter load, which is 160 kg, have a greater maximum trip compared to the heavier load. So here we can conclude that the battery consumption actually increases 0.08 kilowatt hour per 100 km with the increasing 1 kg load. The third test field is the long distance highway of 242 km, which is from RNR Serdang to Tol Plaza Air Hitam. In this evaluation, two test car has been used, which is electric vehicle UIDE 6 and also internal combustion engine ICE Proton X70. So both car is kept constant at 90 km per hour, and for the Proton X70, the mileage will be observed. As a result, two graphs, which is battery percentage versus distance and battery percentage versus time for the EV has been plotted. Both parameters shows a similar pattern, which is average battery drop of 0.31%. So the EV can actually travel approximately to 312 km. For the evaluation, a comparison have been made between EV BYD and ICE Proton X70. For the same average speed and total distance, the energy consumed by EV is 19.20 kWh and 7.8 liter for the ICE cars. And then the cost has been calculated for the energy consumption. Since the fuel price for RON 97 used by ICE is RM 2.53 per litre, it is calculated that the total cost per 100 km is Rm 19.74 for ICE. However, for the EV, the calculation is made by three different tariff which is tarif A, tarif B and tarif D. So the total of Rm 4.19 for tarif A, 6.2 for tarif B and Rm 5.57 for tarif D. Here we can see that the EV is not only energy efficient, but it also can save a lot of money compared to the ICE cars. The second part of the project is the development of motion sensor with IoT-based data logger system. This system device will help to support the analysis on performance of battery consumption in terms of accelerometer and gyroscope. This is the block diagram of the developed system. First, we have MPU6050 motion sensor. It is a sensor which provides data on 3-axis accelerometer, 3-axis gyroscope and also a temperature. And then Node MCU will transmit sensor data to the IoT platform. And then the blink system will act as a wireless communication to send the output data on the smartphone through Superchat widget. The displayed data will be in form of chart in the widget Superchat. Why we said that is a data logger system? Because all the collected data will then be logged into CSV file for further analysis. The picture below shows the simple circuit configuration. The preliminary result will show the MPU6050 orientation on the output graph. If we look at the z-axis, it is kept constant near value of 1 due to the effect of gravity, indicated that it is parallel to the direction of gravity. This is the initial orientation of the MPU6050. If we tilt to the right side of the x-axis, it will give negative value, positive value for the left side. If we tilt upward, it will give negative value and positive value when it is tilted down. That's all for my PSM1. In PSM2, I will perform on-road testing using the developed system device and analyze the performance of battery consumption in terms of accelerometer and gyroscope output. That's all for me. Thank you very much for your time, especially to both my panels, Dr. Zulaily and Dr. Amely, as well as my supervisor, Dr. Khairul Anuar bin Mohamad. Thank you. Assalamualaikum.